Hello students, welcome to the video lecture on Introduction to Matrices. I am Kamini, Assistant Professor, Department of Statistics. In this video lecture, I am going to introduce about matrices and different types of matrices. Matrix is a set of ordered numbers arranged in rows and columns. The size or order of a matrix is determined by the number of rows and columns in that it holds. A matrix with m rows and n columns is named an m by n matrix or m cross n matrix, while m and n are described as its dimension and or we can say it as order of the given matrix. We can call this as a rectangular matrix if m and n are not equal, where m is the number of rows of the given matrix and n is the number of columns of the given matrix. When number of rows is not equal to number of columns, then we call the matrix as a rectangular matrix. Here we have an example of rectangular matrix of order 2 cross 3. Here matrix A has 2 rows and 3 columns. Next we are going to learn more about the types of matrices. We have different types. One is row and column matrix, square matrix, diagonal matrix, etc. We will see one by one. Row matrix. A matrix having only one row is called a row matrix. In general, the order of the matrix is m by n. If m is equal to 1, that is number of rows is equal to 1, then the matrix will be a row matrix. In our previous example, we have a 2 by 3 matrix. If we remove the second row, the resultant will be a row matrix, or we can say that it is a matrix with 1 row and 3 columns. Next, column matrix. A matrix having only one column is called a column matrix. Here is an example of column matrix of order 3 cross 1. Here we have 3 rows and 1 column. Square matrix. If the number of rows and the number of columns in a matrix are equal, then it is called a square matrix. That is, here m and n are equal. Diagonal matrix. If all the elements except the principal diagonal in a square matrix are 0, it is called a diagonal matrix. The principal diagonal is nothing but in a square matrix is a set of terms aii for which the rows and column indices are same. So from the upper left element to the lower right element. So that is called principal diagonal. If all the principal diagonal are non-zero, then it is a diagonal matrix. Here is an example of 3 cross 3 diagonal matrix. Always a diagonal matrix is a square matrix. The special thing that it is all the non-diagonal elements of this matrix are 0. That means only diagonal has a non-zero elements. Scalar matrix. A scalar matrix is a special type of diagonal matrix. If all the entries of main diagonals or principal diagonals are equal scalars, then the diagonal matrix is called a scalar matrix. So in our previous example, we have 3, 2, 5 in our principal diagonal. So if all the diagonal elements are same 5, 5, 5, then it is called a scalar matrix. Identity matrix. If the elements of a scalar matrix are equal to 1, then it becomes an identity matrix. See, identity matrix will also connected with a diagonal matrix. In our diagonal matrix, we have different elements in the principal diagonal, and in our identity matrix, all the diagonal elements are equal to 1. Then it is called an identity matrix. Next, upper triangular matrix. A square matrix in which all the elements below the principal diagonal or 0 is called an upper triangular matrix. That is, for all Aij, I is less than j or zeros. The subscripts I is less than j or zeros. Here we have an example. So, A1, A2, 1 is equal to 0. A2 is I equal to 2 and j equal to 1, where I is less. That is for all Aij, I less than j or zeros. Lower triangular matrix, a square matrix in which all the elements above the principal diagonal or 0 is called a lower triangular matrix. Null matrix. Null matrix, a 0 matrix is a matrix that has all its elements are equal to 0. Since a 0 matrix contains only zeros as its elements, therefore it is called as a null matrix. Next we will see about submatrix. A matrix obtained by deleting some of the rows or columns of a matrix is said to be a submatrix of the given matrix. Here we have a matrix A with 2 rows and 3 columns. If suppose I delete the third column, the resultant matrix will be of 2 cross 2, order 2 cross 2, then it is a submatrix of the given matrix A. Or suppose if I delete the first row of the given matrix, then I have only 1 row with 3 columns, then it is also a submatrix of the given matrix. Next we will see some special types of matrices. First one is idempotent matrix. If we have a matrix say A, then it will be idempotent only when it satisfies the given condition A square equal to A. That is, idempotent matrices or matrices that remains unchanged when it is multiplied by itself. So, here is an example of idempotent matrix. So, here we have a 2 cross 2 matrix. If I multiply the matrix with the same matrix, the resultant will be the same. So, A square will be equal to A, then the given matrix is a idempotent matrix. Next one is the nilpotent matrix. A square matrix M of order n cross n is termed as a nilpotent matrix if m to the power k is equal to 0, where k is a positive integer and it should be less than n. Let us consider the following example, the following matrix, which is of order 2 cross 2 and all the elements in the matrix are greater than 0. If we multiply matrix with itself, the resultant matrix will be a null matrix. See, here A is multiplied with A and the resultant will be a 0 matrix, a null matrix. Hence, this matrix A is a nilpotent matrix of order or index 2. The next special type of matrix is involutory matrix. An involutory matrix is a square matrix whose product with itself is equal to the identity matrix of same order. A square matrix A of order n cross n is said to be involutory if involutory matrix if and only if A square equal to I, where I is a identity matrix of order n cross n. Here we have an example. Let us take A is a 2 cross 2 matrix. If we multiply A with again A, the resultant will be the identity matrix of order 2 cross 2. Next, the transpose of a given matrix. What will be a transpose of a given matrix? Let's have a matrix M and if we want to take a transpose, if we want the transpose of the given matrix M, we need to interchange the rows and into columns. If we interchange the rows into columns, then it is called the transpose of the given matrix M. Here in this case, the first row becomes the first column and the second row becomes the second column, and so on. The transpose of the matrix is given as M to the power T, is denoted as M to the power T or M dash. Okay. Next one is symmetric matrix. A square matrix is called a symmetric matrix if its transpose is equal to the original matrix itself. The symmetric matrix is defined as A equal to A transpose. Here we have an example. The given matrix A is 4, -1 and -1 and 9, right. So, if we transpose the first row, if we want to take transpose for the given matrix, we need to interchange the rows into columns. The first row is 4 and -1. If we take the first row as first column and the second row as second column, the resultant will be same as the original matrix. Hence, the given matrix A is a symmetric matrix. A square matrix A is called a symmetric matrix if its transpose is equal to the matrix itself. Okay. Otherwise, we can say if Aij denotes the entries in the ith row and jth column, then the symmetric matrix is represented as Aij is equal to Aji. Hope you understand about different types of matrices. Thank you.